And so this is a mobile health application called NDN-Health that we were using as a driver in the NSF Future Internet Architecture MVP program last year. And sorry, forgot. And so the driver for NDN-Health is sort of a move from a centralized notion of personal health data to one that's more sort of peer-to-peer and distributed. So this actually is from a paper that's not related to open mobile health, but is about the use of blockchain in moving from a sort of hierarchical picture of care where there's a single provider and consumers of that data to a peer-to-peer architecture where, with the patient as the keeper of their data, there are many participating organizations that in this case use blockchain to maintain a distributed ledger of what they're doing with the health data. And so we have a similar sort of inspiration in the NDN-Health project, which is the idea of a health data ecosystem where named data is at the center of the architecture used for exchanging data between capture of health data like time, location, fitness information, processing, and visualization and feedback. And so this is not from an NDN paper. It's from a paper by Ida Sim and Deborah Estrin, who's now at Cornell. And it was really a data-driven model for health information exchange that looks suspiciously like an NDN architecture with named data at the middle. And so there were a number of limitations of using TCP/IP-based architectures for NDN-Health, not the least of which is sort of the mismatch between a data-driven architecture and or a data-driven app architecture and facing a network architecture like TCP/IP. And certainly the centralized approaches to data management and connection-based security. So a particular pain point, for example, was using OAuth to authenticate different autonomous services that they wanted to chain together. And so the trouble that they were having became some of the inspiration for us to work on an NDN version of NDN-Health. And so this is really using the application as a driver for experimentation and trying to address these limitations. What we want to show you in this demonstration is called NDN Fit. It's an example app that actually consists of a number of different components that sort of envisions what a open data interchange for mobile health actually looks like. So you're going to see an app running on a handset to collect health data, two nodes running in the cloud for storage and processing, a visualization application that runs in the browser, a very simple example of what that looks like, and then all of these things connecting via the NDN testbed. I'm going to skip ahead just briefly to show you the namespace and then turn it over to Haitao that's going to do the demo. So this is a more complicated namespace than maybe the previous examples that you've seen today, but if you break it down into pieces, it actually is very logical and a useful way to organize this data ecosystem. So the root prefix identifies what kind of data that we're talking about. There is a trust anchor that belongs to that root prefix that in our example is owned by the owner of the data ecosystem, which might simply be a foundation that operates it on behalf of an open community. There are identifiers also at a high level that are identifying user and service related data. We're just going to focus on user data in this example. There are certificates that are issued to apps that are owned by users and to users and services that are part of the ecosystem. There are different kind of core data types, like a physical activity data type that belongs to a given user. And then there are the actual data manifests or catalogs for those data. And then there is the encryption keys used to encrypt these individual data records at a granularity that makes sense for the application. And Haitao will talk about a specific example of that in a second. And you'll notice that there's an access control namespace that talks about a certain type of operation that's permitted using the available encryption keys. And so I'm not going to try to explain that in more detail till we do the demo. And so with that, I'm going to go back now and turn it over to Haitao to give you the demo of these different components.
So as Jeff just said, this is a health application. So we use fitness, specifically time location data, to do this demo. So for health data and for fitness data, so what the user cares actually are two things. One is the authenticity. So that means the data consumer needs to know the data is really come from the user it claimed to come from. The second one is privacy. So the data owner can share the data with whoever or whichever entity the user wants to, and other entities and also users cannot access the data. So that's the motivation. So in the app, you can see we basically solve these two problems using NDN's features. So we have already set up the system on NDN testbed. We have the trust anchor running. We have our own system provided data storage unit, data processing unit, and data visualization unit. But actually, those components can also be provided by the user itself. So the user can try to program his own those components, the trust anchor, the processing unit, the storage unit, the visualization unit. Here, we just provide one to demo. So on the phone side, so first, of course, we need to set up NDN connectivity. So we used NDN Android, so introduced by Alex this morning. So we just need to connect to the testbed. So I just pick up a random node here. So that's the UCI node. So we use NDN Android to register the prefix. So that means that's a default prefix. All the traffic from starting from this Android device will go to the testbed. So now I register the prefix on the testbed. So that's the root prefix. And then we start to use NDN Fit application. So the first thing we want to do is to do the authenticity. So we use an application called Identity Manager for the user to request a cert, or say a key, or say an identity from the standard trust anchor. So to use this one, the user needs to provide the email. So why the user needs to provide an email? Because we want to bind this identity with this user's email, and this is a two-step process. So it's two-step because we want to verify this user really owns this email. So first, we go to the email address to check the email. So if the user really owns this email, then the app will generate a self-signed cert, and then the app will send this cert to the trust anchor, and the trust anchor will send the issue a certificate for the user, and we will get another email to tell us, okay, now we have the cert. So now the user has a cert, so as shown here. So we can also see from the website. So that's the Trust Anchor website. So previously, so that's a preload page. So we have some certificates here shown here. So I just request for a new one. So if we refresh this page, then we can show that we can see that now there are 5. So that means a new certificate is issued to this user. And then we used another app called Access Manager. So to use this app, we need to request an identity, or say a cert from the identity manager, so that app can produce the data. That's the access manager. So we also need to issue a cert for this app, so the app can produce data for the user. So now this app gets a cert from the other app, the identity manager. So now we have the trust chain, where the trust anchor issue a certificate to the user. The certificate is stored by the identity manager, and then identity manager issue another certificate for this access manager. So this access manager actually uses next access control. It's just shown by Jeff. So
just skipped over pretty quickly. So if you want to explain a little bit more about it.
Okay. So for this one, for NAC, we need to create different keys: C key, E key, and different kinds of keys. So this app actually can control the access to different granularity of the user's data. So let's say now I'm trying to say that I create a schedule. So each entity joins into this schedule can access the data falling into those time period. So starting from July 1st to August 31. So let's say we only allow data access from noon to midnight. So that's this schedule. So we have the schedule, then we need to join some entity into the schedule so they can access the user's data. So I predefined two entities. So that's the standard DPU and DBU. We join them into the schedule so they can access the user's data. So now access control is set. So we use NDN feed to collect the raw data now. The same thing is we also need to use identity manager to issue a sub-certificate for this app. So now we just click start tracking. So the app starts to track the data. So what I want to show you is actually you can see that I only register a default prefix on the testbed. I did no configuration on the testbed. So, but I use remote prefix registration on the testbed. So the testbed actually now have a bad entry. So all the interest starting with my prefix can be routed to my phone. Then the data can be served. So you can see that now we have the prefix on the testbed. Yes. So this one is just the user we just created, and then we have the prefix register back to my phone. So now we are collecting the data, and the data will be automatically uploaded or say fetched by the storage unit. So I just said we have some predefined DPU and DBU. So actually that's the data visualizing unit. So to run this DBU, we just need to run NFD on our own computer and visit this website, and we get this DBU, and we can try to scan users to see if the user's data is there or not, because it takes some time for the storage unit to get all the data. And also to show the namespace, to show all the data, they actually follow the namespace. We have a name visualizer here. So actually that's the trust relationship we defined in this app. Oh, maybe it's a little bit more. So the trust anchor sends DPU and DBU. It also sends user's key, and user's key sends application key, and application's key sends the real data. And here that's the data we fetched from the website. It takes some time to be stable. You can see that the application's key now moves from this branch to enter the user's key. So that's a trust relationship. You can see that the real data now actually follows the trust relationship we define here. And also,
we should take a second here to explain exactly how this visualization is generated. So this is a NDN.js application that issues interests to the testbed, and basically enumerates data, or in this case, key relationships. Keys are data too, right? So it's enumerating the keys and then visualizing the signing relationships between those keys. So if you mouse over one of those, if this is the right version, you'll see that there are actually NDN names that correspond to each of these nodes. And what you're seeing is pulling this data off of the testbed line, just to be clear about that visualization.
Yes, this is so this tool actually fetches all the keys under the prefix org open house, and also try to build a trusted relationship. And another one is the naming tree. So that shows the data. So it fetches all the data under the prefix org open house from the testbed, and it also builds a tree, the name tree, the namespace. This namespace, you can see that it actually follows what Jeff just shows. We have the users branch, the search branch, and some other users branch, and also DPU DVU branch. And for access control, so if we use this tool, it's easier to explain. So for a specific user, so it can issue some read branch. So this read branch is some keys used to. That's the key. Okay, I need to put a mouse here. So we use the E key to encrypt the C key, and we further use the user's key to encrypt the D key. The E key and D key, they are key pairs. So when we try to decrypt the data, so we first try to fetch the data. We got the data and the C key, and the C key is encrypted by the E key. So we try to fetch the D key, and D key is encrypted by the user's data. So if the user has the key to decrypt the D key, then we can further decrypt E key and then C key and then the data.
We'll show you a picture right now.
Nobody knows what the E key, D key. So we hear the following very simple picture. Data, your health data is encrypted. You don't want everyone to see it. But your doctor can see it. You want to give a doctor permission. So what you do is you have a decryption key that can be encrypted by the doctor's public key. You got it? So only the doctor can fetch it, then decrypt it, and get the decryption key to decrypt your data.
And so the schedule that Haitao was talking about is basically creating new names or new sub-name spaces every hour, and having content encryption keys associated with a particular hour granularity. So if you want to give your doctor all your data, you give them an encryption, you give them access to all of those keys. If you want to just give out an hour's data to your workout partner, you give them just the key for that. So there's a trade-off between key granularity and the level of access control that we're providing. And so a lot of the E key, D key, all that exchange is probably what Lisha summed up. There's just one additional level of detail where we're using names to organize the granularity of access.
So fundamentally, think about it. Okay, if you want to have the user to control your own data, the fundamental question is how do you manage all this encryption, decryption? And NDN find a way to automate this. So this is just the tool for explanation. You as the user no longer have to worry about those. The system, you just define who can get your data, the system can execute. Only your designated person can get the data. I think security is a fundamentally missing piece in today's big data in IoT. Yet NDN is coming to help with that.
And this encryption is just what I just said. So the user just wants the entity that it grants access to access the data. So here now the system runs for some time, so the data must be produced. So that's the user we just produced, and then we try to. So now the DBU here is an option to say whether we want to decrypt the data or not. So now we just do not click check this one. So we try to fetch all the data. Okay, we fetch some data, but you can see that because the data is encrypted, so it's not the real JSON format. So the parsing packet process actually will fail. So if we click this one, so because this is a DBU, you just see that in the when we use the access manager. So actually we allow the DBU, the second one, to decrypt the data. So if we click this one to try to decrypt data and try to get all the data again, so yes, you can see now we can get the real data in the data packet. So that means if you encrypt the data for the DBU, then it can decrypt the data. So you can encrypt your data for anyone you want, and the access is only controlled by the end user. And also, previously we have grant DPU access to the data. So we can call the DPU here. Actually, we just said we run the DPU. So the user's name is this one.
So DPU is data processing unit. And so again, the model in this application, remember, is distributed processing. So the DPU is doing a calculation. In this case, it's going to be a simple bounding box on the latitude and longitude. And the DPU portion is a collaboration with Christian Schuden's group at the University of Basel to use named function networking, which is a kind of, think of it as a layer on top of NDN, though I'm not sure Christian thinks of it that way, where you can basically articulate functions that get functions to which you pass parameters using NDN names, and those functions could be performed by any device on the network that's able to execute them and can decrypt the data and then publish the result. And so here, what Haitao is showing is now kind of an intermediate process being run on that source data. And it's a simple one, a bounding box that's passed back to the visualizer.
So we calculate this bounding box, and the bounding box will show on the map, and also the DBU will just log all the dots on the real Google map. So if we are really moving, then you can see the real path. But we just stand here doing nothing. Oh, actually, that's the previous data. It's not the current user. Maybe I picked the wrong username here. But still, you can see that all the data, time location data, they are logged on the map. So if we move now from here to the source compass and come back, you can see the real path. You can provide your own DPU and DBU to do any calculation you want, and you want to view your data in any form you just want.